integrated 2, 922, lesson 922. I'll be honest with you, I got a feeling this is going to be a long video. I hope you guys stick with it. It is, I would argue, important stuff. A lot is going on in this video. It's going to tie together a lot of things. So please stick with it, even though it will probably not be exciting. All right, so solving systems of equations. Essentially, this goes back to integrated 1, when we had two lines. That's what a system was. Hopefully you recall. We had two lines that could meet in one intersection, no intersections because they're parallel, or it could be the same line twice and you could have infinity. But what happens when we have like two parabolas, or two parabolas, or two parabolas, right? They might touch twice, once, maybe they'll touch exactly once, maybe they'll look like this, who knows, right? What if we have a parabola in a line? Maybe it looks like this, maybe it looks like this and they never touch, maybe it looks like this and they touch exactly, well, that didn't go well, but exactly once. You know what I was going for there. So that's really the goal of what we're looking at today. So hopefully we can get through this. So when we look at 961, it says, consider the functions f of x equals x squared minus 2x minus 8 and g of x equals negative 2.5x minus 3. Graph both functions on the same set of axes. How many times do the graphs intersect? And estimate the points of intersection. So I have these jotted down and I'm going to go over to a coordinate plane and work with these. So hopefully you guys will follow along. Like I said, f of x and g of x have these things jotted down. So I will go to a coordinate plane and we will work on these. So f of x was x squared minus 2x minus 8. I'm going to give myself some room to work with that there. And g of x equals negative 2.5x minus 3. So first thing, I'll graph f of x. I have a y-intercept at negative 8. So I'll come down here, 6, 7, 8. I hope you guys are becoming comfortable with the different forms and how they go across. Keep that cheat sheet handy until you don't need it anymore, but you absolutely need to be able to go back and forth and understand what's happening here. All right, so first thing I'm going to do is I'll try factoring it with the diamond to get my x-intercepts, and it looks like I'm going to get lucky there. Negative 4 and positive 2. Negative 4 times 2 is negative 8. Negative 4 plus 2 is negative 2. So this is going to equal x minus 4 and x plus 2. Which means my x-intercepts are 4, 0, and negative 2, 0. So I'll go to negative 2, 0 and put a point, and I will go to positive 4, 0, and I will put a point. I can work my way in to get my axis of symmetry, but instead what I'll do is I'll just I'll complete the square on this. And again, I'm going to kind of go through this quickly because we've spent a lot of time on this, so hopefully you guys are comfortable with this already. Get rid of the number you don't want to make room for the number you do. Obviously, I'm going to factor out a 1 there, which doesn't affect the problem at all. I'll take the perfect number, which is half of this. Half of negative 2 is negative 1, and negative 1 squared is positive 1. If I add 1 to this side, again, it's just 1 times 1, so it's just 1. I'm going to add 1 there. I get 9 equals. If you complete this, if you make this a perfect square, you're going to get x minus 1 squared. I don't know if you guys noticed the shortcut, but once you have this perfect square here, it's just half of b is going to be what goes here. So this will be x half of b. I'll subtract 9, and I'm going to get 0 equals x minus 1 squared minus 9. So my vertex is going to be 1, negative 9. So I'll go put that in. I have a point of symmetry here, because that's obviously my axis of symmetry. I have my x-intercepts. I don't think I care enough to mess too much with what's going on here, so I'm just going to estimate that it looks something like this. I know that these points are solid. Once I get up here, it's fuzzy and just an estimate. Now I'm going to go here and I'm going to graph this one. So 1, 2, 3, negative 3, and I go down 2.5 and over 1. And down a half and 2 more and over 1, and you can see this is a definite intersection. 2, negative 8 I feel real solid about because it hit the line and it hit the curve, and I know that this is a point for both. Up 2.5 over 1, up a half, up 2 over 1, up 2.5 over 1. This one I'm not as sure about. I don't know that this actually hit a point. I do need to estimate it. So negative 3, 1, 2, 3, 4.5. again, but this is just an estimate. I do not feel confident about this because it did not hit that. That point isn't a lattice point. A lattice point means it hits where I know it's an X and a Y. That's hitting in the middle. I'm totally guessing. I have no idea where it's at. I don't even know if -3 is correct. Just because it looks like -3 doesn't mean it definitely is. Whereas over here, I know it's 2, -8. All right, so let's jump back over and keep working. So we estimated the points there. It says 962, use a graph to determine the intersection of two curves. Using a graph to determine the intersection of two curves can be challenging when points of intersection are not where the grid lines intersect or outside the visible portion of the graph, which we just found, right? It was not obvious to me what that one point was. One was, one wasn't. Therefore, it helps to have another method for determining the points of intersection. What algebraic methods have you used to solve systems of equations? Discuss with your team members. Well, back in integrated 1, we used equal values method. We used elimination and substitution. So I hope you guys remember those different things. You might want to look them up if you forgot. Obviously, we're going to do some of them right now, but still be good to review. Those are things you should definitely know. So use one of the methods you listed in part A to solve for the points of intersection in this. So here's the thing. This f of x, it really just means y, right? We named it f of x. And this g of x really just means y. We named it g of x. So don't forget that this function notation is just us naming different lines so we don't get confused which ones we're talking about. If I say, I didn't do the fill in there. If I say, hey, plug 2 into that equation, well, you don't know which equation I'm talking about. But if I say plug 2 into f of x, you know I mean this one. If I say plug 2 into g of x, you know I mean this one. So they really both just mean y, though. So I'm going to exploit that. If this equals y and this equals y, well, then they both equal y. They both equal each other. So x squared, that's an x squared. I knew that was going to happen. I should not have done that. Okay, let's stick with this. So x squared minus 2x minus 8 is going to be set equal to -2.5x minus 3. I could move all of this over here, but I would get a negative x squared, and I don't want that. So instead, I'm going to add 2.5x and add 3 to both sides. I think that is going to be better for me to end up a positive. So I get something that looks like this. So a little bit unusual. I have a decimal here. I'm still going to try the diamond anyways. I suspect I might get lucky here. So a times c is -5. B is 0.5. I have my x here. And I did get lucky, right? So 2.5 times -2 gives me -5, and 2.5 minus 2 gives me 0.5. So I can rewrite this equation as y equals x plus 2.5 and x minus 2. So I know this one here is going to be x equals 2, right? We'd already discussed that. This one, I think I estimated it -3, but it looks like it's actually -2.5, and I didn't know that by looking at my graph, but I do know that algebraically. That's the advantage of algebra, is you're going to get the correct answer instead of an estimate. Now I don't have the y values, so the question is, how do I get the y values? Well, normally this is just our x-intercepts, right? So we know that the y value is 0, but that's not what's going on here. We had something that looked like this, where these were our x's. We know our x's are -2.5 and 2. What we don't know is our y. So we can simply plug 2 into this equation and it'll spit out a y. And we can, we should plug it into here and into here and see that we get the same answer. So I'm going to go up here and I'm going to plug in 2 and see what I get. And I think it's pretty easy. I'm going to do this one on my head. -2.5 times 2 is -5. -5 minus 3 is -8. And we were very confident about this point to -8. But we should still confirm it in this equation. If I plug 2 in for x, I should still get y equals -8. 2 squared is 4. -2 times 2 is -4. So 4 minus 4 disappears. And I have -8. So this point I feel very solid about. What I don't feel solid about is this negative 2.5. So I'm going to plug it into this equation, see what I get. Then I'm going to plug it into this equation and make sure I get the same thing. And if I get the same thing twice, just like I did with this, then I'll know that I'm right. So I have g of x, or actually I should just call it y, right? So y equals negative 2.5x. I'm going to plug in negative 2.5 minus 3. A negative times a negative is positive. 2.5 times 2.5 is 6.25. So I get y equals 3.25. Okay, now I was not personally going to be guessing that by looking at my graph and my estimate. Again, I think I guessed like negative 3 and positive 4 or something like that. So you can see it's a little bit different than my estimate was. But what I need to check is plugging this negative 2.5. I know what I get when I plug it into this one, but I also need to plug it into this to see that it confirms. So I will do that. I will plug it into both. Y equals negative 2.5 squared minus 2 times negative 2.5 minus 8. Again, a negative 2.5 times negative 2.5 is positive 6.25. Negative 2 times negative 2.5 is positive 5 minus 8. So you can see I'm going to do this part first. 6.25 minus 3, right? 5 minus 8 is negative 3. So y equals 3.25. So it worked for both of them. So I feel pretty good that this is my second point. Again, I estimated something totally differently, but I have my 2 points of intersection. So that's how we're going to determine what these 2 points are. You'll remember from that graph. A lot going on with this lesson. Like I said, I hope you guys stay with it. We'll do another example or two of this, but I don't expect this to be a short video, and I do expect it to be a little bit tricky. So, moving along. We have answered 61 and 62, so we'll go to 63. It says, consider these equations. Sketch the graph of both equations. I'm just going to do this real quickly. X squared, we've seen this a million times. It just looks something like that, right? 0, 0, 1, 1, negative 1, 1, 2, 4, negative 2, 4, 3, 9, negative 3, 9. Hopefully that makes sense. This one, my y-intercept is negative 5. I'm going to go up 2 over 1, up 2 over 1, up 2 over 1. And we're asked to estimate our points of intersection. Well, I don't think there are any. It looks like there aren't. It looks like they miss. So it says use algebra to solve the system of equations. How does your solution relate to what you found in part A? So we'll do the same thing we did on that previous step. We're going to use algebra. We're going to use equal values method. We'll put them equal to each other and we'll solve. We'll say, hey, look, this equals y. And this, I hate to keep doing that. I keep forgetting to take that off. We're saying this equals y and this equals y, so they must equal each other. Again, I want to work with a positive a, so I'll do it this way. I get x squared minus 2x plus 5 equals y. You can see my diamond's not going to get me very far here. 5 and negative 2. The only numbers I can think of are 5 and 1 that multiply to 5. Halves aren't going to work. There's no fractions here, so my diamond's not going to work. So I'm going to use the quadratic formula. B is going to be negative 2 here, and C is going to be positive 5 here. A negative, remember, it's negative b plus or minus the square root of b squared minus 4ac over 2a. By the way, this part of it right here, inside the square root, is going to be really important later in this lesson. It's called the directrix. No, it's not called the directrix. It's called the determinant. And it's going to help us determine how many solutions these have. But we'll worry about that in a minute. For now, we'll just follow this through. So a negative 2 is 2, plus or minus. Negative 2 squared is 4, minus 4 times a times c. All that is over 2a. So I get, make myself a little more room here, 2 plus or minus the square root of 4 minus 20 over 2. So 2 plus or minus the square root of negative 16 over 2. I hope you guys recall that the square root of negative 16 is just going to be the square root of 16 and the square root of negative 1. The square root of 16 is plus or minus 4. The square root of negative 1 is I, that imaginary number. So this is going to be 2 plus or minus 4i over 2. You can see so many things going on with this problem, so hopefully you guys are remembering this stuff. 2 divided by 2 is 1. 4 divided by 2 is 2. So my solution is 1 plus or minus 2i. Well, what does that mean? Well, I is an imaginary number. If you think back to multiple choice tests you've taken in the past, a lot of times it doesn't say no solution. What it'll say is no real solution. And I don't know if you guys have ever noticed that, but the reason it says no real solution is because there is solutions. It just happens that they're imaginary. So this does have imaginary solutions, just not real solutions. In the real world, these don't ever touch. But if you go to the imaginary number line, they actually do touch, which is really weird and not in the scope of this video to really kind of elaborate further. This video is going to be long enough. But again, it is possible, which is weird, to have no real solutions, but imaginary solutions. Okay, so we will continue along here. Again, I want you to keep this determinant right here is going to be a big deal. So make sure you guys remember this b squared minus 4ac part of this. It's going to come up later. At this point in class, I would break you guys up into groups and ask you to do the same thing for a couple of more problems. But I'm probably going to do A completely, and then we're going to talk about the 3 problems we just did, and then we'll look at B, C, and D to sort of see if we can use what we've learned. I hope you'll see what I mean in a minute. This is kind of a weird lesson, and there's a lot going on, like I said. So, all right, so first thing is this. They ask us to go through, use algebra to solve this. Hey, look, this equals y, and this equals y, so they must equal each other. I'll subtract 2x and add 1 from each side to get them all together. I will use my diamond. I get 1 and negative 2. So you can see I'm going to get x and negative 1, right? That's a negative 2 down there. Negative 1 times negative 1 is 1. Negative 1 plus negative 1 is negative 2. So this equation turns into x minus 1 times x minus 1 equals 0. So my solutions are x equals 1 and x equals 1. I don't know if you guys recall, but we said when we have the same thing twice, right? This could be rewritten as x minus 1 twice. I'm sorry, x minus 1 squared. X minus 1 times x minus 1 is x minus 1 squared. Anytime you have that, you're looking at your vertex, but whatever. So now we'll plug in what is 1 squared? Well, my y would be 1. Because don't forget, well, actually, I guess I'll go here. What is 1 times 1? It's 1, so my y would be 1. I'll confirm that here. What is 2 times 1 is 2, minus 1 is 1. So I get the same thing either time. So my solution would be 1, 1. This is where these two shapes are going to meet. This parabola and this line are going to meet at 2, 1. So what I wanted to do was sort of jump over real quickly and show you in Desmos these problems that we have set up. So first of all, the first problem that we did, you can see it met at 2, negative 8 and at negative 2.5, 3.25, just like we said. The next one we had didn't meet at all. Again, we did have some imaginary solutions. And the one that we just did is supposed to meet at 1, 1. And you can see right there, it meets at 1, 1. It doesn't meet twice. It just sort of kisses the parabola and keeps going. So that's where we're at with that. So if we jump back over, the question would be, what are we doing here? And is there a way to sort of help us with this? How do we know if it's going to have 0 solutions, 1 solution, or 2 solutions? So I asked you guys to keep the determinant in mind, which is b squared minus 4ac. When we determine this, if this is positive, we're going to have 2 solutions. If this is negative, if it's negative, we're going to have no real solutions. Remember, we will have imaginary. And if it's 0, we'll have one solution. So that's really what we're looking at here when we solve these. So let's go ahead and confirm that that was the case. We had x squared minus 2x minus 8 is equal to negative 2.5x minus 3. You'll recall this problem had two solutions. So I get x squared plus a half x minus 5. So my a is 1, my b is a half, and my c is negative 5. If I go to this, b squared, 0.5 times 0.5 is 0.25 minus 4 times a times c. Again, I don't even care. Oh, that's supposed to be a negative 5. Sorry. I don't even care what the answer is here. I just care if it's positive, negative, or 0. So you can see I get 0.25. Negative times a positive is negative times a negative is positive. Plus 20. So I get 20.25. It's irrelevant to me what the number is here. All I care about is it's positive. I should have two solutions here, and I do. If I go down to this next one, x squared, you'll remember this had no solutions. So this should have a determinant that is negative. So let's see here. I get x squared minus 2x plus 5. My a is 1, my b is negative 2, and my c is 5. I go to b squared minus 4ac, right? My b squared is 4, minus 4 times a is 1, times c is 5. I get 4 minus 20. I get negative 16. Again, I don't really care what the number is. I just care that it's negative, which means I have no real solutions. So if I go down to this one we just did right here, x squared equals 2x minus 1. If I subtract 2x and add 1, I'm going to get x squared minus 2x plus 1. Again, we had one solution here, so I'm expecting my determinant to equal 0. So a is 1, b is negative 2, and c is 1. I hate when I do that, when I go from colons to equal signs. Anyways, b squared is negative 2 times negative 2 is 4, minus 4 times a times c. So I get 4 minus 4, which is 0, just like what we expected. So we know that this one has one solution. So we can go do the same thing for b, c, and d, right? Shouldn't be that difficult. I'm not even going to waste my time getting the solutions. I shouldn't say waste my time, but I just want to know how many solutions it has, how many real solutions it has. So let's do b. X squared minus 5x plus 6 equals negative x squared. I add x squared. I get 2x squared minus 5x plus 6. Again, our directrix is negative, is b squared minus 4ac. That's what we're doing. And plus means 2, negative means 0, and and 0 means 1. Right? That's what we're talking about here. So here, I get b squared, negative 5 times negative 5 is 25, minus 4 times a times c. I get 25, I get negative 8, negative 48. I get a negative number, negative 23. So I know I have 0 real solutions. If you want to run over to Desmos or something like that, or use algebra would be even better, feel free to confirm that that has 0 real solutions. I go here. X squared minus 4x plus 5 equals negative x squared plus 4x minus 1. I'll add x squared minus 4x and add 1. So I'll add x squared minus 4x and add 1. You can see I get 2x squared minus 8x plus 6. So b squared is positive 64 minus 4 times a times c. I'm definitely going to get a positive here. 4 times 2 is 8 times 6 is 48, so I get a positive 16. So this must have two solutions because it ended up being positive. Then we'll go here and we will do d. So x squared minus x minus 2 is equal to x squared plus 2x plus 1. I'll subtract 2x squared. I'm sorry, x squared minus 2x minus 1. So minus x squared minus 2x minus 1. These cancel out. I get negative 3x minus 3. So my A is 0, my B is negative 3, and my C is negative 3. So B squared is 9 minus 4 times A times C. Well, you can see that cancels out. It's going to be 9 minus 0, so I get 9. So this has two solutions. Hopefully that all makes sense. There's a lot going on here, so not an easy lesson. I really wish we were in school. Well, I guess potentially if you're watching this in the future, maybe we are, but I'm taping this during the corona. 922A. So let's go ahead and finish this lesson up. I don't think it's going to let me. Okay, so I'm going to close this and reopen it. Alright, so to finish up, it says algebra comes to the rescue, and we're going to use that determinant right now just to sort of make this faster for ourselves. So it says, Daryl's so excited when he calls his local radio station during a contest. He is the 9th caller. Talk show host Maribel explains that Daryl will win a brand new graphing calculator if he answers this question correctly. How many times does the parabola y equals 2x squared minus 5x and the line y equals 2/3 x minus 4 intersect? He uses a graphing calculator and looks like this, but what should he say? Should he say there's one intersection? He does know that he can use the determinant to see if that can help him out, so that's what we'll do. We'll use a determinant and we'll see if we get one solution or more. There we go. Alright, so we get 2x squared minus 5x equals 2/3 x minus 4. I will subtract 2/3 x and add 4 to each side. I will get 2x squared minus 5 and 2/3. We'll just call it minus 5.6x plus 4. My A is 2, my B is negative 5.6, repeating actually, and my C is 4. So B squared minus 4AC. So B squared, negative 5.6 squared. So negative 5.6 squared, I'll just do that, equals, oh, I see. You guys, it's an interesting point. This video is long enough already, but what it did is order of operations. It squared first, and then it did the negative. I should have actually put it like this. So I ran into an order of operations problem there, because it should be positive. We know a negative times a negative is positive. So the reason why it wasn't, again, is I didn't put the parentheses, so it squared first, and then it multiplied by negative 1. So I get 32-ish minus 4 times A times C. So 32, a little bit more. A negative times a positive times a negative is negative. 8, 32. Well, this is a little bit more, right? It was 32.11. So 32.11 minus 32 is 0.11. So it is positive. So there's two solutions. We actually would have got two solutions there. So let's go ahead and I'm going to jot this down, these two equations, so we can see that there are indeed two. So we're going to go back over to Desmos, and I am going to put these things in. And on this one, it was 2/3 x minus 4. You can see it only looks like one solution, so let's zoom in. And you can see if we zoom in that we do indeed get two solutions there. So algebra and that determinant to the rescue indeed. Helped us win a free graphing calculator. How awesome was that? I apologize for the length of this video, but again, I will say I think it's a very important video, so I hope you guys follow along. Pause it, fast forward it, rewind it, whatever you need to do, but make sure you get this lesson.